Okay, question number 7C. So it's gonna take a little bit longer. That's why I wanted to do it separately. So question 7A and B, I already did it. So stating an alternative hypothesis, carry out a chi-square test at the 5% level to decide if the following data can be modeled by the binomial distribution. Okay, let's state the two hypotheses, right? The null hypothesis, we can say that the data can be modeled by, let's say, can be modeled by by this binomial distribution, which is 0. I really hate it. Do it again. 0 null hypothesis can be modeled by, let's do it like 5 and 0.35. Okay, yep. And then no alternative hypothesis, no, cannot be, no, not by no binomial distribution. Please write it down in a very good way, okay? Not like me. This is not good. I'm showing you the wrong way, actually, and then you can do the right way. Okay, now let's do the test. But before, we need to know how many times this is happening, right? What is the total observed value? So 15 plus 49 plus 65 plus this and this and this. We have 180 values actually. What I'm gonna do, so this is 0 time happening, 1 time happening, 2 times, 3 times, 4 times, right? Take out your calculator and write it down. 0 time 1, 2, 3, 4, 5 times happening. And go to the distribution, binomial distribution, binomial probability distribution. So this is going to be from list 5. So the number of trials is 5. What is the probability for 0.35? We need to save your values. Let's save list 6. Okay, click on it. This is your probability values. But this is for 1 time happening. We have 180 observed values. So go to the list 7, option, list 6 times 180. If you do this 180 times, those are the observed, the expected values. If you do it 180 times, those are the expected values. However, we have a problem over here. The problem is, if you want to do the chi-square test, any expected or any observed value cannot be less than 5. Let's see, do we have any values less than 5? This is okay, this is okay, this is okay, and this is okay. This is not okay. What I need to do, I am going to combine this, the 5th and the 6th values. Okay, I'm going to combine. If you combine your expected values, you have to combine your observed values too. This is gonna be 10 plus 5, which is, this is 10 plus 5 now, 15. And then the expected value here, I'm not going to write it down, but just show. Here it's going to be, this part is going to be 8.7786. Please write it down, all numbers, because then your test is going to be very accurate. Okay. And 5625 plus this value, right? The whole thing, 0.94539375. Let's do it over here then. Go. Oops. Okay, here. So this value, I do not know how to write it. That's why I just write it down all. 8.77865625 plus 0.94539375. I don't play any computer games, that's why I'm very slow. No problem. Okay, this value, just delete it. Go and delete this value. Now this is your expected value. Let's say the expected one list 7. Let's write it down to list 8 observed values. Okay, let's go to the list 8 and write it down to observed value. Be very careful, we already combined the 4th and 5th. Okay, this one. So 15, 49, okay, 65, 36, and 15. Okay, now let's do the test statistic. Go to the test, chi-square test. This is goodness of fit, right? So you are not looking at are they in a relationship or not. You're looking at are they okay or not. Go to this. Your observed value is list 8. Yeah. Expected value list 7. Is this okay? Degrees of freedom. Now we combine this to, as long as we combine it, let's count it. 1, 2, 3, 4, 5. 5 minus 1 is the degrees of freedom. Okay, no need to save it. Click. As long as you don't have the critical value, you do not have to look at this x chi-squared values. Okay, just look at the probability. The probability is 0.1897. Now think about it. The chi-square looks something like this. Okay, you are looking at 5%, right? Let's say this is the 5%. Now your test statistic is something like 18%. So this is the confidence level for the H null hypothesis, right? So that means we are going to accept the null hypothesis. We can say that this can be modeled by binomial distribution. Is this all right? This is clear? Yep. So when I looked at the answer key, yes, that's all right. Okay, let's see the question number 8.